This won't be bad. Under probability, the little subheading, children, is the multiplication rule. And this is something you want to know because this has practical applications for everybody. And let me write it down here. If you have two, let's make sure I get it right. If an experiment has two parts, the first with m possible outcomes and the second with n possible outcomes, then the total number of possible outcomes for the experiment is m times n. Wait, that's not what I want to do, sorry. Write this down. You can cross that off, because that doesn't. This is what we're talking about. If events A and B are independent. What's it mean to be independent? They don't rely on each other. Then, you've heard of if-then statements. The probability of A and B, let me do it like this, probability of A and B is the probability of A times the probability of B. So with that being said, let me just give you your homework, because that goes without being said, right? That needs no explanation, correct? Yes, it does, or no, it doesn't?
It needs an explanation.
It needs an explanation. Well, let's try to explain it. Here's the deal. What that means is this. Let's say you're doing two things. Let's say you're flipping a coin. Let's say you flip a coin, and here's my coin. What do you want to call it? We got Abraham Lincoln. And let's say we've got a spinner. And this is 1, 2, 3, 4. These two are independent events, which means when I flip a coin, it has absolutely nothing to do with the spinning the spinner. Like if I get a head on that, that's not going to change what my probability is for that. If I asked you the probability of flipping a head and spinning a 4, okay? If I asked you what the probability that Cameron Atkins would flip a coin and get a head and then spin a 4, to figure that out, you just multiply their individual probabilities together. In other words, this. The answer to this is the probability of flipping a head times the probability of spinning that 4. What is your probability of flipping a head? 1 out of 2, right? What is your probability of spinning a 4? 1/4. So the probability of both of those happening at the same time, or not at the same time, but back to back would be 1/8. 1 out of 8 times you should flip a head and spin a 4. Which makes sense because if you did a little probability tree, okay, your first event is you're either going to get a head or a tail, right? And then after you flip a head, you're either going to get a 1, a 2, a 3, or a 4. Or if you flip a tail, you're going to get a 1, a 2, a 3, or 4. Your sample space is what? H1, H2, H3, H4, T1, T2, T3, T4. But I only want H4, and H4 is just 1 out of 8 possibilities. Does that make sense? So you ask, what would be the probability then of this? Probability of taking a deck of cards, drawing the Jack of Hearts, and flipping a tail. I can tell you it's not very good, is it? What's the probability of, so you take the probability of drawing the Jack of Hearts, which is what? How many Jack of Hearts is in the deck of cards? 1 out of how many cards? 52. And what's the probability of flipping a tail? 1/2. Probability of doing both of those? 1/104. That means if I actually let you do this, it probably you'd go around the room probably 5 times before somebody would actually do that. Which makes sense because just the probability of you flipping the Jack of Hearts is going to be pretty goofy, right? 1 out of 52 times, you have to go twice and then flip that. Let's see what other questions they ask you. So here's a question. Write this down. A bag has 2 red and 3 blue marbles. Bag has 2 red and 3 blue marbles. Bob selects a marble from the bag. Bob picks marble. Then replaces it. Then replaces. Just like Obamacare, we are going to, what's the keywords they always say, all these presidents? We are going to repeal and replace. You guys gotta start watching the politics, it's very comical. He then selects a second marble. Then picks a second marble. What's the probability he selects a red and then a blue? Probability of a red, then a blue. And it doesn't really matter what order he does it in. He could do blue and red. It's really not going to change the probabilities, I don't believe. So here's my bag, right? Inside the bag is 2 reds and 3 blues. And I want to know the probability of a red and a blue. Well, the probability of red is, how many reds are there? Out of how many? 5. Now here's the deal, and this is very key. You have to watch when it says this. It says that he picks a red marble, okay, but then he puts it back in the bag. Okay. If he puts it back in the bag, nothing's going to change for the blue marble because you still have the same number of marbles and they're still all 3. There are still 3 out of 5 are blue. Later on, we're going to get to the point where he doesn't replace the marbles, and that changes your probability. But if you replace it, it's not going to change it. So what's the probability of a red then a blue? You multiply those 2 together, you get 6/25. 6 out of 25 times he should pick a red and then a blue, or a blue and a red. It's one of each. Ain't that funny? Ain't that exciting? Look at page 460 just quickly here, because I know you are very anxious to get to work. Look at the practice with that little spinner there. Look at the directions. It says, in a certain experiment, a coin is tossed and the spinner is spun. Compute the probability of the events in A and B. What is the probability that you'll get a head and a blue? Probability of a head and then a blue. Well, what's the probability of a head is 1/2. What's the probability of spinning a blue? 1/3. So the probability of both of those happening is that multiplied together, which is 1/6. Letter B. What's the probability of a heads and not blue? Probability of heads and not blue. Well, the heads is still 1/2. Probability not blue is, how many not blues are there? 2. How many total? 3. So when you multiply that together, you get 2/6, which is 1/3. Any questions on probability?